Melissa Hooper is one of our graduate students at Duke University, and she'll be speaking to us today about mapping changes in water supply distribution in Rome under Claudius, which is part of a larger dissertation project under the direction of Melissa.
I also want to thank, as many of the other speakers have, thank the Ancient World Mapping Center and Gabe and all the people involved in organizing this conference. I've had a wonderful time so far and look forward to getting your feedback and questions on my project. So, water is an essential resource for every human population, and its supply and control were necessary to sustain Rome's large urban population. Ancient authors like Pliny the Elder and Suetonius marveled at the two new aqueduct lines, the Aqua Claudia and Anio Novus. This is from outside of Rome, part of those aqueducts. They were completed by Claudius, who ruled from 41 to 54 CE. From the time they were built and for several decades following, these two aqueducts provided nearly half of the city's total water supply. The construction of many beautifully ornamented public fountains distributing water from new aqueducts must have impacted residential communities from both a practical and a visual standpoint. Clean water had to have meant more to the people of Rome than the reconstruction of a new temple in the Forum. Studies of building in the city of Rome tend to overlook infrastructure improvements despite being crucial to sustain the population. The kinds of projects tackled during Claudius's reign were more functional rather than flashy. He built aqueducts, roads, a portico for grain distribution, and a new port. When Claudius came to power in 41, there were 6 aqueducts supplying the city. The Aqua Virgo had been disrupted by the construction of an amphitheater by his predecessor Caligula, and the building of the Aqua Claudia was in its early phases. In this paper, I use archaeological evidence, epigraphic material, and ancient data from Fontinus's treatise on the aqueducts to map in GIS the diachronic changes in water supply and distribution under Claudius. Visualizing this change allows us to consider building as a process and understand the impact disruption, repair, and construction of aqueduct lines had on particular regions of the city. The results of the visualization show that Claudius improved the potable water supply in areas where the poorer population of Rome likely lived, particularly in the floodplain of the Tiber River, which I argue is a testament to the emphasis on the people over lavish munificence during his reign. I will begin with an overview of the ancient sources and methodology used in the visualization process, and then present my maps and interpretation. To the extent that it was possible, I mapped the data relevant to the water supply under Claudius in ArcMap using Lothar Hasselberger's Mapping Augustan Rome map as a base, and the University of Virginia's Waters of Rome project as a starting point for my data. A significant body of archaeological and epigraphic material survives from the ancient aqueducts of Rome, thanks to evidence in situ and the documentation efforts of scholars like Rodolfo Lanciani, Thomas Ashby, and many, many others. This allowed me to map the courses of the aqueducts into the city, including both above-ground and underground channels. Claudius's monumentalization of the above-ground conduits with rusticated travertine columns and descriptive inscriptions preserves some key information for the change over time in the water supply. The well-known Porta Maggiore, which many of you who have been to Rome I'm sure recognize, it records the dedication of the Aqua Claudia and Anio Novus in 52, and inscriptions on the Aqua Virgo, the aqueduct here. We have inscriptions documenting the rebuilding process, with part of the repair finished in 44, date from that inscription there, and completed around 45, that arch inscription there. I would like to look more closely at this inscription from 45 CE because the text provides the evidence for the disruption of the aqueduct by Caligula. Okay, so we've got Tiberius Claudius Caesar, titles, gives us 45 CE. The important part is in bold, rebuilt and restored to their original site the arches of the Aqua Virgo destroyed by Gaius Caesar, Caligula. With 41, the beginning of Claudius's reign, 45, and 52 CE as my key dates, I was able to create 3 separate maps to document and assess change over time. Much like the Forum of Augustus, which we know was used prior to its dedication in 2 BCE, the aqueducts could have begun supplying water prior to the official dedication date, so these dates are simply providing a terminus ante quem for the aqueduct's completion. While we have a substantial amount of information on the aqueducts, they did not carry water directly from the source to individual fountains or homes, but instead terminated in castella, basically water collection tanks. An example of a castellum can be seen in this 18th century engraving by Piranesi, and you can see the Porta Maggiore off in the distance. We believe that this was the castellum for the Aqua Claudian Anio Novus right there. So from these castella, the water was distributed via a network of fistula, which were lead pipes. Thousands of fragments from these pipes in Rome survived, but unfortunately not enough to reconstruct the distribution network on a micro scale. Christa Brun estimates that we have about 4 to 5% of the total number of fistulae from the ancient period, and of that 4 to 5%, only half have well-recorded find spots. Of all the fistula found in situ, we have 3 stamped with the name of Claudius. I've included the find spots of the Claudian fistula in the map. Fortunately, Sextus Julius Frontinus, who served as the water commissioner under Nerva in 97, preserved information on the regional distribution of water in his treatise on the aqueducts of Rome. No new aqueducts had been built between the reign of Claudius and the time Frontinus was writing, so his treatise can serve as a useful source for the water supply of Rome during the Claudian period. For each aqueduct, Frontinus identifies which of the 14 Augustan regions it supplied. So while a lack of evidence prohibits a small-scale reconstruction of the network, we can look at distribution on a larger, more regional scale. Here, I want to note that the definitive boundaries of the 14 regions remain a subject of debate, especially as to how far they extended before you reached an outer border. Most maps of these regions will use the Aurelian Wall as an outer border, but that wall wasn't built until the last quarter of the 3rd century CE, way after the reign of Claudius. I've used the boundaries defined by Filippo Corelli, but have not placed an outer border on the regions, so they may have been larger or smaller than shown on the maps, likely smaller. So now let's take a look at the maps. What I have here, hopefully you can see it. I've recorded to the best that I could. So we've got the number of aqueducts supplying the region. This is our first map from 41 CE, the start of Claudius's reign. 1, 2, 3, and 4 are our colors for the different regions. Then also water features like fountains, nymphaeum, springs, castellum. You can see some of those locations of water collection tanks, cisterns, and then inscriptions, the aqueducts, the boundaries, the fistula, and then aqueducts, and then visible aqueducts. That's meant to be where we have exposed arches that we can see. Okay, so that's 41. Here's 45, when the Aqua Virgo was repaired. And here's 52, when the Claudia and Anio Novus were completed. One of the first things I noted was that the areas with the greatest amount of change over time are regions 7, 9, and 14, right here. In 41 CE, region 9 in the Campus Martius received water from 3 aqueducts. By 45, it received water from 4, and by 52, from 5. Region 14, here, the Transtiberum, or area across the Tiber River, received water from 4 and 41, 5 by 45, and 7 by 52. Meaning that by the end of Claudius's overhaul of the water supply system, only 2 of the 9 major aqueducts did not reach the region. The Transtiberum was physically separated from the monumental center of Rome, but became an increasingly integral part of the city's economic growth from the Augustan period onwards. Coarelli describes Transtiberum as a working-class neighborhood based on inscriptional and archaeological evidence for such things as brickmaking, port structures, and mills, to name just a few. The need to improve water supply may be a reflection of the growth of the residential population and commercial activity in the region. As Gregory Aldretti has shown in his book on the floods of the Tiber in Rome, these areas were consistently threatened by flooding, making this land less desirable and thus where the poorer residents of Rome likely lived. So in this slide I illustrated the point I interpolated the Augustan Rome contour data and conducted then GIS watershed analysis and floodplain modeling for what Aldretti defines as the typical flood in Rome 10 meters above sea level. So you can see I've shown you Campus Martius clearly inundated in a typical flood, as was the Transtiberum, the region 14. Another major point brought to light by mapping the data was the importance of the Aqua Virgo. I would argue that its disturbance served as the catalyst for the initial construction of the Aqua Claudia under Caligula for the sake of having redundancies in the water supply. Compared to the 14 regions supplied by the Aqua Claudia and Annia Novus, the Aqua Virgo only supplied 3 regions, which we can see here. Well, maybe you can't see here because it's a light pastel purple, but it's the 3 regions the Aqua Virgo supplied were 7, 9, and 14, right there. The Aqua Virgo supplied the needs of the Campus Martius and also furnished water to the Transtiberum, which both Robert Lloyd and Harry Evans suggest was the first extensive distribution to that district. Though the Campus Martius was partially supplied by the Aqua Appia, Annia Vetus, and Marcia, the quantities reaching these regions must have been quite low compared to those closer to the Castella. So notice that the Castella are mainly on this side of the city. The Aqua Virgos, notice that almost all of the aqueducts entered the city from the east. The Aqua Virgo source is also east of the city, but its course was designed to skirt north of the city and then take a sharp turn south into the Campus Martius. A similar argument can be made about the Transtiberum region. It was technically served by 4 aqueducts in 41 CE, but the Alciatina was undrinkable. Frontinus actually states, "I fail to see what motive induced Augustus, a most wise sovereign, to bring the Alciatinian water, for it has nothing to commend it. In fact, it is positively unwholesome, and for that reason is nowhere delivered for consumption by the people." As for the Appia, Annia Vetus, and Marcia, only small amounts would make it all the way across the Pons Aemilius, to the Transtiberum. So these aqueducts that did serve Transtiberum had to all go via the Pons Aemilius. Compare the location of this bridge to the point of access for the Aqua Virgo, the Pons Agrippae, further north in the region, allowing more dispersal throughout. This is all to show how important the Aqua Virgo was to these regions and to the people who called them home. Caligula may have underestimated the importance of this one aqueduct when he destroyed part of it in the construction of an amphitheater, cutting off supply. Around the same time, construction began on 2 aqueducts which would serve all 14 regions of the city. I believe that redundancy in water supply was key here. When Claudius came to power, he did not bother completing Caligula's amphitheater in the Campus Martius, but instead destroyed it and focused on getting the arches of the Aqua Virgo rebuilt. Claudius made both a practical and a visual statement by leveling an entertainment venue, restoring the largest source of water to the low-lying regions, including water for the only public bathing complex at the time, imperial public bathing complex at the time, the Baths of Agrippa. And finally, he commemorated it all with an inscription. Some additional data from Frontinus on the water supply can confirm just how crucial the aqueduct projects completed under Claudius were to supplying the people of Rome. Despite serving only 3 regions of the city, the total quantity of water brought intra-urban, inside the city, by the Aqua Virgo was third, behind only the Claudia and Ania Novus. And the majority of this was for public use, not private or imperial. Frontinus breaks down the distribution of water intra-urbem into three categories: nomine Caesaris, imperial use; privatis, private use; and usibus publicis, public use. The usibus publicis category is further divided into castra, which were water collection tanks; munera, fountains; laci, public pools; and opera publica, public works. Carlos Nareña and others believe that the majority of the population would draw their water from the laci. But Brun notes that people could have also obtained water from munera and opera publica. Of course, we must also recognize that there were other sources of water, like wells, cisterns, and springs, to supplement this supply, but the dearth of evidence makes it hard to estimate their impact. I'm aware that Frontinus's figures for the total volume of water flowing into the city are problematic because of a flaw in his unit of measurement, the quinaria. A quinaria is equivalent to the diameter of the smallest Roman pipe. Thus, the quinaria only measures capacity and does not account for changes in the velocity of water flowing through the aqueducts or pipes. However, this problem was not unknown to Frontinus because he does mention attempting to take measurements at points where the velocity was similar to other times he was taking measurements. Regardless, I'm not using these numbers for exact quantities, but to show general trends. So the following bar graphs and maps will illustrate those trends. The first shows the total number of quinaria dispersed inside the city for 41, 45, and 52, with each bar divided up between imperial use, private use, and public use. Notice the spike in use, in public use when the Aqua Virgo is repaired, and how the total water supply doubles in 52 from 41, with the Virgo, Claudia, and Ania Novus in commission. Then, this next chart only includes data for public access water supply, divided up between laci, munera, and opera publica. Again, the increase in public access water supply is massive, with just the repair of the Aqua Virgo in 45. But absolutely huge when the Claudia and Ania Novus were completed. We can also consider the data by aqueduct. The Julia, Tepula, and Marcia ran concurrently to one another. So I've combined their total quinaria into one in this visualization. Even those three combined, according to Frontinus's numbers, did not surpass the Aqua Virgo in total water supply. Hopefully you can see this, both the width of the aqueduct and its color change based on, it gets darker and wider as you have more water coming into the city. But in terms of public use, the Aqua Virgo is clearly the most important because it's supplying the most public use water supply. One of the many powers of GIS in the study of ancient history is to contextualize and visualize data in new ways that can yield new interpretations and perhaps even more questions. Being able to map both the courses of the aqueducts and their regional distribution over time highlighted the prominence of the Aqua Virgo, a restoration project of Claudius that receives considerably less attention compared to the Aqua Claudia and Ania Novus. The results of the visualization show that Claudius did indeed improve the potable water supply in areas where the poorer population of Rome likely lived. No new forums or temples were built under Claudius, but repairing and rebuilding aqueducts assured that all regions of the city had sufficient water, even if one or more of the aqueducts were disrupted. Thank you.